So hi everyone, in this video we are going to talk about the generalized pigeonhole na principle. So the generalized pigeonhole principle states that assuming there are n objects or n pigeons that are going to be placed into k pigeonholes or k boxes. So there is at least one box containing at least the ceiling of n over k na object. So again, n refers to the number of pigeons and the k refers to the number of pigeonholes. Okay, so let us try to have an example. So assuming we have 8 pigeons here and we have 4 na pigeonholes. Okay, so by the generalized na pigeonhole principle, at least one box will be containing at least n over k, or that will be equal to 8 pigeons divided by 4 pigeonholes, which is equivalent to 2 na objects. And we can see here that assuming all of the pigeons are placed in only one pigeonhole, then it complies to this result where there is at least one box that contains at least 2 objects. So in this case, this one pigeonhole contains all of the pigeons, which is equal to 8, right? So what about this? Assuming that only 2 pigeonholes are used. So we have this first, the pigeonhole, which has 4 na pigeons, and then another na pigeonhole, which has 4 na pigeons. Okay, so still, this complies to this principle wherein there is at least one box that contains at least 2 na objects. Okay, so what about this one? In cases wherein, assuming that these pigeons are evenly distributed, so it means that these 2 na pigeons will be mapped into this one pigeonhole. So essentially, each pigeonhole that we have will have 2 na objects by the pigeonhole principle n over k, right? So we are just dividing all these pigeons into each of the available pigeonholes that we have. Okay, so now what if the number of pigeons is not divisible by the number of pigeonholes? So for example, we have 4 pigeonholes and we have 9 pigeonholes. So 9 divided by 4 will be equivalent to 2.25. Okay, so we cannot actually subdivide this extra pigeon into different pigeonholes, right? So what we can do is this pigeon will be shared, will be sharing with the other na pigeons, all right, in one na pigeonhole. Okay, so what we can do is to just use a ceiling na property. So wherein we take the ceiling of n over k, or in this case, the ceiling of 9 pigeons divided by the 4 na pigeonholes. So that is equivalent to the ceiling of 2.25. And the ceiling of 2.25 is equal to 3 na objects. Okay, so essentially what we do is just to round up this number into 3. Okay, so now we have at least one box containing at least 3 na objects, and we can see that this is true. Okay, so while the other 3 na pigeonholes are evenly distributed with 2 na pigeons, we have one pigeonhole which has 3 na pigeons. Okay, so let us have an example. But before that, what would happen if like I empty this pigeonhole and transfer these 2 pigeons into this pigeonhole? So you can see that still it complies with this result wherein at least one box contains at least 3 objects. So in this case, this pigeonhole contains 5. Okay, And what if all of the pigeonholes are using only one pigeonhole, I mean? So still, the generalized na pigeonhole principle remains true. Okay, so we can see here that still this one box, we have one box that contains at least three objects. Okay, so in the next part of our discussion, we will have some examples and show how we can use this generalized pigeonhole principle.